How can two things that are both invisible and infinite be different? How can a tear in the fabric of the universe, where time stops and light is swallowed, wear distinct faces? In the infinite intricacy of the cosmos, black holes exist in many forms: tiny, silent, gigantic, or theoretical, each one cloaked in shadow, but each one telling a different tale. Each is a variation on one theme, disappearance. But within that disappearance lies variety. And within that variety, truths about space, time, and our own place in the universe. In this video, we will not only explore the types of black holes discovered and theorized by science, but delve into why those differences matter, why the universe crafted them with such diversity, why understanding their classifications isn't just about physics, it's about understanding the fabric of reality itself. We will journey from the birth of the cosmos to the centers of galaxies, from dying stars to potential time loops. This is not a lesson in astronomy. It's a meditation on the edges of existence. Imagine a quiet night. The stars above are still. But somewhere out there, one of those stars has reached the end of its life. It collapses under its own weight. And in doing so, tears open the cosmos. Not with a bang, but with a silence so profound, even light cannot escape. That tear is a black hole. But not all black holes are born the same way. Some are ancient, older than the galaxies themselves. Some are born from chaos. Others from inevitability. Some we have seen, others we only suspect, and one kind might not exist at all. Modern astrophysics recognizes four main categories of black holes. 1. Primordial black holes, PBHs. These are the ghosts of the very beginning. Hypothetical black holes formed mere moments after the Big Bang. Instead of being formed by stars, they are the result of quantum fluctuations and density variations in the infant universe. Their sizes could range from a grain of sand to a mountain, or perhaps even smaller. Though we have never observed one, they are considered candidates for the mysterious dark matter that shapes galaxies from the shadows. If primordial black holes exist, they are not just scientific oddities. They are fossils from creation itself. 2. Stellar black holes. The most well-known type, formed when massive stars reach the end of their fusion fuel and collapse. Typically 5 to 100 solar masses in size. They lurk in binary star systems, often revealing themselves by how they devour a companion star's matter. Some spin at incredible speeds, dragging the very fabric of space-time around them. These are the black holes we detect most frequently, via gravitational waves or X-ray emissions. 3. Intermediate black holes, IMBHs. The cosmic middle class. These black holes range from hundreds to hundreds of thousands of solar masses. For decades, their existence was debated, as evidence was rare and indirect. Recent findings, including strange patterns in stellar motion and gravitational waves from unusually massive mergers, have strengthened their case. IMBHs might be the missing link between dying stars and galactic giants. 4. Supermassive black holes, SMBHs. Titans among titans, found at the center of most, if not all, large galaxies. millions to billions of times more massive than our Sun. How they form is still a mystery. Did they grow from smaller black holes? Or were they born big? The most famous, Sagittarius A** at the center of our Milky Way. And the black hole in M87, the first ever imaged in 2019. They regulate galactic evolution, control star formation, and shape the very destiny of galaxies. These four types do not merely differ in mass. They differ in origin, in behavior, and possibly, in purpose. Picture the universe as a vast ocean. Primordial black holes are like ancient pebbles dropped into the sea at the moment it was born, their ripples still felt, but never seen. Stellar black holes are whirlpools left behind by sinking ships, stars that burned bright and then collapsed. Intermediate black holes are hidden underwater trenches, vast, unexplored, and mysterious. Supermassive black holes are deep maelstroms at the heart of islands. They don't just pull in matter. They anchor entire ecosystems. Same ocean, different forces, same cosmos, different expressions of gravity's wildest dream. But why does the universe craft so many versions of absence? What does it mean, that nothingness has taxonomy? If all black holes eventually erase space, time, and information, why bother with difference at all? Unless that difference is the point. Perhaps primordial black holes whisper the origin. Stellar ones teach us death. Intermediate ones guide us through mystery. And supermassive black holes hold the keys to creation. Maybe black holes are not cosmic garbage disposals. Maybe they are edit points, portals, wombs. They are not just where things end. They might be where something new begins. To classify black holes is to attempt the impossible, to sort the formless. Yet we try, because in naming, we hope to know. In dividing the darkness, we seek understanding. These black holes, from the size of atoms to the mass of galaxies, form a spectrum of awe. Each one invites us to look closer, to listen longer, to wonder harder. They are not merely objects. They are metaphors, etched into reality, proof that even the void has structure, that even the silence of space has different voices. We thought the black hole was the end, but by studying its types, we realize it's only a beginning. In our next chapter, we go even deeper. Are black holes the architects of the universe? What if these cosmic monsters, instead of destroying, are actually designing galaxies, balancing matter, and sculpting space-time? What if behind their terrible pull lies the hand of creation? Join me, as we look beyond the edge of light, and ask not what black holes take away, but what they leave behind. Because in the darkest places, we often find the brightest questions. And in the silence of the void, the universe may be speaking its most profound truth.